time for the Ragdoll sim. So first, before we do anything, I'm gonna go into this crowd. I'm gonna drop down a color. And this is just, we can see the horses a bit better. Like that. And I'm actually gonna, this makes no sense that it's called crowd sim. Let's call it crowdsource now. And this is the crowd sim. Right, okay, so we need two things. One thing is that we need to get the collision geometry into the simulation, and the other thing is that we need to have a way to trigger in them. So the first thing I think we should do is that we should just look at the environment and then try to get the timing right of this thing. So let's show here, and then look at it. Here they're running. Oh, we are looking at the height field right now. One thing I want to address is that I think it starts too early, so I want to time shift. I want to time offset it a little bit. So let's drop down a time shift. So there's a time shift, and I'm going to make it start 30 frames later. And just because this will be outside the cache range, I need to clamp it as well. So now they're going to start a little bit later, and this looks better to me. Cool. The other thing I'm going to do is when it comes to environments and collision geometry and all that, you want to have as little of it as possible into the simulation. So in this case, for example, it's just moving within a little part of it. So we don't need all this part here. And if we remove that, everything's going to be faster. So let's crop that out first. So I'm going to have a delete here. I'm not going to connect it because it's much faster if I just take this bounding volume. I'm going to select, and then I'm going to see where this is. So let's move it. Let's see where they start. Start over here. So let's go there. And then something like this. And then let's connect that. And then we're going to have delete non-selected. Actually turning earlier. So let's remove this as well. Cool. All right. And let's make a null and call this out crop. But before I bring this into the simulation, I actually want to do the triggering first. And the reason for that is that as soon as I bring this into the simulation, everything will slow down. So let's just do the triggering, and then we can add the actual collision geometry. So let's go in here. And how am I going to do the triggering then? The thing is, because I know they are train projected on the ground, I can measure the distance between them and the ground. And if that is too far, then I know that the ground is probably crumbling under them. Let's measure that distance. So I'm gonna go in here, I'm gonna drop down a trigger, and then let's have object distance position, and I want to have it on closest point. So let's select the out crop, and then we're gonna have a transition, and we're gonna have from run to Ragdoll. I want the duration to set to 0, and I want to connect that to the last port here. And like so. And so let's see what we have before we do anything. And now you can see they're all falling immediately. Not what we wanted. Oh, obviously we need to make a different comparison. So we're going to see if it's bigger than 0.15. Then we know that they're off too far from the ground. But they're still falling through it. And the reason for that is that I messed up with the height field. So if we go into the environment here, and then just have a look at this and go to the first frame, you can see that they are going through the ground, and that is just because the height field doesn't have enough resolution. So let's take this grid spacing down to 0.5, and now you can see they are moved up. And by doing that, if we look at this now and play it, going, here they come, they get triggered, and yeah, let's turn on the environment. When the environment starts breaking, they're gonna fall down. Another problem is though that we can see that it just freeze and falling straight down. They don't have any momentum. And that is an easy fix if we go into the crowd sim. And by default, this run state is set to ignore. And that means when it gets triggered to Ragdoll, it just comes with no information because it's not part of the bullet simulation until it's in the Ragdoll state. So all the velocities are disregarded. And we don't want that. We want them to remember the velocity, and that is easy. Just change this to animated static, and by doing that we now see that they will fall forward. You see, keeping the momentum. Cool. All right. So that looks pretty good. Well, let's put a camera to this. I just want to have something that we can go back to. So let's go here, and I'm just gonna go to the camera here and control click. So now we have this camera, and now let's bring in this actual collision geometry, because now they're just falling on this to this ground plane. So go in here, gonna remove the ground plane and have a static object and have that in, put that to deforming, and then we're gonna point to the crop. And if we rewind this and go to the bullet data and show guide geometry, we can see everything is just one big chunk. We have to set this to create convex holes per set of connected primitives. And by doing that, now you can see we have all the pieces. Sweet. Right, okay. So let's go out and go to the camera and make a flipbook. So if we look at this, you can see they're running here, falling. Whee! Looks kind of cool. One issue though is that they just kind of dies, and all the legs gets completely floppy, and they're very much like ragdolls. What we would expect is that they would move their legs when they were falling down, and that we can do with the help of motors. And with motors, you can take a clip, and then you can blend that into the ragdoll sim. And you can choose to even have the whole agent being affected by that clip, or you can just choose parts of the agent to be affected. And in this case, I actually just want the legs to be affected. And how you select what part of the agents you want to use is that you set up transform groups. So let's go out and leave this, and then go. And you do that in the agent definition. So if you look at this agent definition cache, you can see we have transform groups as one of the things that gets saved. So let's drop down a transform group here and put that before the agent definition cache. And let's hide everything except that guy. I'm going to turn on show guide geometry. So what you do, you define what change are going to be part of the transform groups. And if we would look, let's call this legs. And if we would look at our transform, we can see all these transforms, they are calling something with leg. So we can use a pattern match. We do star, leg, star. And now we can see that the leg chains are included in these groups. I also want to taper off the effect, because now they are equally affected, but I want to blend it. So I'm going to have this blend ramp in here. By these being darker show that they are less affected by the group. These guys will be affected the most, and these the least. So that is cool. Let's just save this again, reload, and then we can go into the simulation. So go into the simulation here, up to the ragdoll, and here when you say motors, let's check that. And in the group, let's select our legs. And then here on the strength value, you can choose, you can have it on constant or ramp. With strength ramp, you can have it affecting the agents differently through the simulation. But in this case, we just want them to be constant and move through the whole simulation. So let's just have that. For the clip, let's choose run. And we can have it on in place because we just want the animation. I'm going to take down the clip speed to 0.5. I'm going to put some variance and offset it. And let's have a look at what this gives us. And let's go to the camera we had before, and then go back, and let's do a flipbook out of this. Okay. So go. Now they are moving their legs when they are falling down. Alright, so let's move on and put some hair on them.